Hello, this is Mr. Painter with another fabulous IXL tutorial. Today we're working on IXL GG.14, checkpoint for two-way frequency tables. All right, let's talk about a two-way frequency table and what exactly does that mean. All right, in a two-way frequency table, the values add up to the ends. So for an example, going to the right, the first value plus the second value will equal the total. Total generally means that. And the same thing, high school students here, whether they play an instrument or do not play an instrument, will equal to the total here. Now, what's interesting about two-way frequency tables, as that is one direction, there must be another direction because it's called a two-way direction. You guessed it. Going down, they also add up. So going straight down, the first box plus the second box will equal down to the bottom row here. And same thing here, going straight down to 2.6 plus the 2.8 will equal the box here. And you can either add these two boxes to give you the total here, or you can add these two boxes to give you the total here by going down. They're actually going to give you the same thing. All right, so what you got to do is use the numbers that they gave you and determine what's missing. So for an example, here plus here equals that. Well, you have no idea because you got three boxes in a row that don't work. Now, if we go to this something called center column, remember columns are up and down, we can add 0.26 plus 2.8 to determine, well, what's that box here? Now, I'm going to recommend on this module have a calculator handy on this because there'll be a lot of adding and subtraction as you go. So what exactly does this look like? We got 0.26 plus 0.28 equals something. So we're just going to go ahead and use the calculator on that one. So we're going to go 0.26 plus 0.28, and that's going to give us a total of 0.54. So we're going to go ahead and plug in 0.54 into that box. So plug in decimal 0.54. Now, that box was pretty easy and straightforward. Now we got to figure out, well, how do we fix this column? So you got to think, well, how do we fix this column? I think you guessed it. We need to use some algebra. So have you ever wondered what those one-step equations for? So check out this equation right here. We got something we don't know, which we call x plus 0.26 equals 0.38. Makes sense? So this is that row right here. So now what we're going to do is use algebra and just simply solve for x. Well, this is something called a one-step equation. One-step equation means in one change, it would automatically be done. So when we do a change, is we're going to take the opposite of 0.26 to get x by itself. So all you got to do here is just subtract 2.6 from both sides, 0.26, and that'll give us our solution. So we have x equals, because those cancel out, and remember we're subtracting, and this one we could do by hand, it's not that big of a deal. 8 minus 6 is 2, and 3 minus 2 is 1. And bring down the decimal 0.12. All right, nice. So we're going to go ahead and plug in 0.12 for this first one here. Now it should be true. 0.12 plus 0.26 equals 0.38. Now you can put the 0 in front if you want. It actually makes no difference. That is the same thing as that. So in case you're wondering, well, I think they're supposed to have a 0 in front. It actually doesn't matter. All that matters is what's to the right of the decimal. All right, now we're going to keep the same concept going. We're going to go ahead and figure out using algebra what this box is by using that row. So I'm going to go ahead and clear the screen because it's getting pretty muddy at this point. But notice that we only got 2 left. All right, let's go ahead and use red for x plus that number we'll give you over here. So we got x plus 0.28 equals 0.62. And what is opposite of adding 0.28? You got it. Subtract 2.8 from each side. And again, I meant to say 0.28. 0.28. And if we subtract on one side, we definitely need to subtract on the other side of that equal sign. All right, now here we got a little borrowing involved, so it just might be easier to use a calculator. We got 0.62 subtract. Be careful with the calculator because all you gotta do is type it in wrong, and you'll be unhappy with the result because one number wrong, you get the whole thing wrong. And we get 0.34. So x equals, because 28s are gone, 0.34. All right, we're gonna plug in 0.34. And our last one, we're going to use the same thing. We're going to use algebra again. So we have x here plus 0.54 equals a total of 1. So we got x plus 0.54 equals, and again, we're just going straight across right here, equals 1. And 1 is the same thing as 1.00. Could you imagine that a dollar is the same thing as 1? Yeah, they're the same thing. All right. Opposite of add 0.54 is subtract. So we're going to subtract 0.54 from one side. But if we subtract it from one side, we need to subtract it from the other side. So minus 0.54. Now the calculator decimals matter, so you got to be very careful. So we're going to do a whole number of 1, subtract 0.54, and that's going to give us 0.46. So if you can imagine, it's like 46 cents plus 54 cents give you $1. Now that just made a lot of sense. So that works out really nice. So just need to finish the problem here. We got x equals 0.54s are out, 46 cents. So we're going to plug in 46 cents. 0.46. Now here's a pretty creative way to check your work, because all of these on the left side in the column we did by hand. It should make sense that if I add 0.12 to 0.34, that it would equal to 0.46. Because if any of these numbers are off, that would make the equation not true, and it would be for sure the problem would be wrong. All right, so let's just simply check that. We can just use a calculator. That's all we got to do is use 0.12 plus 0.34 equals 0.46. So this is all right here. And we know this is right because we just did 46 cents plus 54 cents equals $1. All right. Clear the board. Final box. How many more high school students than middle school students play instruments? All right. So when we talk about play instruments refer to play an instrument. So all this information right here is not used in the question. And also the total is not being used either, because they're just asking for high school students compared to middle school students. Here's our middle school students, and here's our high school students. So we're comparing these two values right here, the 0.12 and 0.34. Because it says how many more high school students play than middle school students, just subtract the two. So we're going to subtract the high school students with the middle school students. So we're going to subtract 0.34 minus 0.12. And again, use that handy dandy calculator. We got 0.34 minus 0.12. And that's going to give us a result of 0.22. All right. And we're just going to go ahead and plug in the 0.22. Now I'm just double checking right here. Music store survey, 50 students. I'm wondering if you got to multiply that 0.22 by the 50 students. Frequencies from the survey. Total of 100%. Yeah, I'm going to try that. I'm going to do 0.22 times 50 and see what happens. Times 50. Does that give us a whole number? Yeah, it does. Now, why did I stop myself on that? Because it says how many more high school students, a fraction of a student isn't a student. I've noticed that right now. I'm like, wait a minute, 0.22 and students doesn't make sense. Now, 11 students makes sense. All right, so what I'm going to do is I'm going to go ahead and change our 0.22, which we multiplied times 50, to give us 11 students. Cross our fingers we get it right. Bam! Worked out nice. See, a little common sense worked out great on that. All right, now we're on a roll. We kind of understand these problems. So notice that we have 150 customers, and these are the frequencies. And when you talk about a frequency or percent, a 1 is the same thing as 100%. So we just take the number of customers, multiply the decimal that we need here at the end. All right, next step. All right, first step, let's do the first row. Okay, the first row we have x plus 0.06 equals 0.44. All right, solving for x, we need to go ahead and subtract 0.06 from both sides, minus 0.06. And now we have x equals, because 0.06 is our opposite, 0.44 minus 0.6. So it's like saying 44 minus 6. But if you want to be particular with decimal, which I'd encourage you to, use a calculator. So 0.44 minus 0.6, I have a hunch that should be like 0.38, 0.06. So be careful with that 0. So now I made a boo-boo. 0.06. And that gives me that 0.38 like I thought. Perfect. All right. So I'm going to go ahead and put in 0.38 for my first value here. So 0.38. All right, next box, clear the screen. We'll do one at a time. Let's address this box right here. And we'll use this row right here to make it true. So as long as we got 2 out of 3, we're good. So we got 0.2 plus x equals 0.56. So here we go. 0.2. By the way, 0.2 and 20 are the same thing. So 0.2, 0.20. You can mess with that later if you want to get more into it, but I'll just put it as 0.20 to match it. Okay, plus x equals 0.56. So the question is asking you 0.2 plus what gives you 0.56? Well, take the opposite of adding. So we got minus 0.20 on both sides, 0.20 subtracted. We're going to get x equals, this one we don't need a calculator. You can just go straight down because look, 6 minus 0 is 6, and 5 minus 2 is 3. So we got negative 0.36 on that one. All right. So negative, why am I saying negative? Positive. I was going to say frequencies can't be negative. So it's just subtraction. There we go. All better. So we got 0.56 minus 0.20, 0.36. All right. Last row. Notice the last row here, we have 2 out of 3 missing, which means we can't go by the row. So what we're going to have to do is we're going to have to go by the column. So we're going to clear the screen and go by the column. So the first box plus the second box will equal the last box. So basically we're just adding. So how do you write this? It'd be 0.38 plus 0.20 equals x, because x is what we don't know. And that's easy enough. Just add them up. We can just do 38 plus 20. That's the way I see it. And if you're unsure, and look at it, it's still in the calculator from last time, so we can just add 20 to it. So plus 0.2. Remember, adding 0.2 and adding 0.20 is the same thing. So it does give us 0.58. So 0.58. And we're just going to simply take that 0.58, plug it in. And now that you get the pattern, we'll just do the other one. We'll just add up 0.06. Don't forget that 0. Now that 0 is very crucial there. And add up 0.36. So 0.06 plus 0.36 gives us 0.42. There we go. All right, clear the screen. We got ourselves a completely filled out frequency table. Very, very nice. Now we need to ask ourselves, how many more customers prefer a window seat than an aisle seat? Very interesting things on airplane. Basically, when you're on an airplane, if you sit towards the middle, it's called an aisle seat. And if you sit on the ends where the window's there, they call that a window seat. Most people on an airplane would like the window because you can see out. All right. How many more customers prefer a window seat? Okay, so now we got to figure out 6 flights a year or less or more than 6 flights. Now, they didn't tell us about that. So what we're going to do here is use the total comparing the window seat and the aisle seat. So what do we need? We need to compare these two right here. All right, so because it says how many more customers, we're going to go ahead and just subtract the 0.58 and the 42. So 0.58 minus 0.42. It's going to give us a frequency. Then we're going to multiply the number of customers. So we got 0.58 subtract 0.42. It's going to give us 0.16. Now, because we have a total of 150 customers on this plane, or in this scenario, we're going to take that 0.16 multiplied by 150, and that's going to give us a total of 24 customers. And there we go. 24 customers would much rather have a window seat compared to an aisle seat. And we're going to turn that in. Perfect. And we got ourselves some literature on this one. But what's nice is everything's filled out for us. We just need to pick the one that works. All right, because the table's already filled out for us, let's look at the literature here and see which one matches the table. But let's kind of get an over idea of, well, what's the scenario? So the scenario is a beverage company surveyed 200 people to find out whether they'd prefer plain water or flavored water. This table shows the relative frequencies. Okay, so we're comparing plain water and flavored water. It could be sparkling water. It could be like a Powerade, because that's kind of flavored water too. All right, anyhow, based on the data of the table, which is true. All right, people under 40 years old are more likely to prefer flavored water than people that are 40 years or over. Okay, so what they're saying is 40 years under. So I'm going to actually get this whole thing. Under 40 years, they want flavored water. Okay, so here we go. Under 40, flavored water. All right. And this part here, 40 years and over, then let's see, that's what they're comparing it to. So they're saying 40 years old and under. See, it's so tricky, huh? Take your time. All right. So under 40, they'd rather have the water. So under 40, they'd rather have the flavored water. But according to this, it says under 40, looks like the plain water is a larger number by exactly double. So that's the part that's getting confusing me, because like this isn't making sense. And when it doesn't make sense, it's a no-go. So check in one more time. Under 40 and 40 years older. Let's go to the 40 years older. 40 years older, well, it looks like they'd much rather have the flavored water. So comparing, it's these two that they're comparing. There's nothing in here about plain water, so yeah, don't need it. 40 years and over wins because they need more. They like flavored water. So people under 40 years old are more likely to prefer. That one's no, because 0.42 is much bigger than 0.3. Because 40 years and older, they want that flavored water compared to the under. All right, clear the screen because the first one is definitely not correct. It was exactly opposite. So don't want that one. Now, did they change to the opposite? People under 40-year-olds are less likely to prefer flavored water than people. Um, that's correct. Under 40, they'd rather have less flavored water than people over 40. So that one looks good. It's the exact opposite of the first one. Now, what makes the last one false if I'm going to pick the middle one? People under 40 years old are likely to prefer flavored water. Say again, people under 40 don't want flavored water. They don't like it. As people 40 years and old and over. See that? No, that doesn't work. So we're going to go ahead and choose the middle one because, again, people under 40 years old would rather not have the flavored water. All right, 3 questions. It's been a long time. It's been 15 minutes, but notice that in 3 questions, we're already a smart score of 50. It does go by pretty quick. So, same thing, the table's given to us, which is really nice. We just need to answer the question. Let's see what the scenario is because I can't answer the question without understanding the overall picture. So I want to know like what the overall picture is here. All right. So for a math project, Aaron asked 50 students at his school whether they prefer apples or bananas. Okay, so we're comparing apples to bananas, and here's the results. So they got girls and boys comparing apples and bananas. So how many more boys than girls did Aaron survey? Okay, because we're talking about survey, we're talking about totals. All right, because we're comparing girls to boys, which means we're looking at these two numbers right here. We're comparing the totals of the girls to boys. Okay, notice that we're not asking anything about apples, and there's nothing about bananas. So again, look at the question. Nothing about apples, nothing about bananas. We're just asking the totals about who got surveyed. And because it says many more, we are going to subtract the boys with the girls. So 31 minus 19 will give us our answer on this one. This one was pretty nice. 31 minus 19 gives us 12. So we had 12 more boys compared to girls were surveyed. So this survey could be a little bit unfair because, usually when you do a survey, you want to try to get everybody equally. So 12 on this one. All right. Another fantastic problem because the table's filled out for us. All we got to do is figure out, well, what's the frequencies. So that's nice. How many more guests prefer pancakes than waffles? Okay, so we're going to compare waffles to pancakes. Now, what they didn't compare was coffee and tea. Now, it's already confusing because I did not read the question. So go back, read the question, and try to understand what's the overall picture here. Nate is a hotel manager. Okay, so a hotel manager is somebody that is in charge of running the hotel. He asked the guests at the breakfast bar if they preferred coffee or tea. Okay, so they're comparing coffee and tea. He also asked the guests if they prefer waffles or pancakes. They're both actually pretty good. This table shows the results. Okay, so we got coffee and tea and waffles and pancakes. So we're comparing two things at the same time. All right, how many more guests prefer pancakes than waffles? So what are we looking at? The overall waffles and the overall pancakes. Well, what does overall mean? The overall means the total. So what are we looking at? The 34 compared to the 41. Because it doesn't say anything about coffee and tea. So coffee, this row's completely out. And tea, not even mention that row's completely out. So that's always a good way to eliminate what you need. All right, the word many more means subtract. We're going to subtract the pancakes to the waffles. So if we have 41 pancakes, subtracted the 34 waffles. So pancakes in this case are more popular. And we're going to have 41 pancake lovers subtract 34 waffle lovers. It's going to leave us with 7 more people would rather have the pancakes than the waffles. So our answer here is 7. All right, back to normal, filling out the table, and then determining the question based upon what we got to do with the table. All right, so starting with the first box here, notice that if I do the row, we have 2 empty boxes in a row, which you can't do that. We only can have 1 missing box at a time. Now, if we do the column, we also have 2 boxes that are missing. So which means this first box is not a good place to start at. So I think we want to start somewhere else that might help us fill the boxes out next to it that might later determine what that box is. So I'm going to clear the screen. The Boys Adventure is probably the worst box to start out with. What about the comedy box right here? Notice that if I do the comedy box for the boys, that if I do the column, we have 2 out of 3, and that one we can do. So we're going to go ahead and make that the X, and we're going to add going down, and it equals the total, because remember the total is where it equals. So we got X equals 0.24. I don't know why I said X equals, because we're adding going down. So what we're going to do is we're going to go ahead and add going down. It's okay to make mistakes. You just got to see it. So X plus 0.24 equals now the total of 0.36. All right, subtract 0.24 from both sides minus 0.24 from both sides. We have X equals 0.24s are out. 0.36 and 24s, that actually sounds familiar. 36 and 24 are bases of 12. So that's going to be 12. Because look, 6 minus 4 is your 2, and 3 minus 1 is your 1. Line up the decimals. 0.12. So we got 12.12 on your comedy. Nice. Clear the screen. Okay, now that's done. Now notice that we have a box over here, and we can also do that by the column. So that one is possible too. So we can do 0.48 plus X equals 1. So remember, 1.00 is the same thing as $1, right? 1 is 1. Subtract 0.48 from both sides minus 0.48. And just use a calculator on this one. It should give us 0.52. So 0.48 minus 0.52. I don't know why I just did that. Clear. 1 minus, I just got that 0.52 in there. 1 minus 0.48. And there's our 0.52. I should have gone with the 0.52 to begin with. All right, so we got 0.52. Careful, sometimes your hand or fingers don't agree with your brain. My fingers were thinking of a 6 and not a 2. So we're going to do 0.52 in our missing box. 0.52. And notice I hit the 3. There we go. All right, that one's done. Now we can go back to the first box because we have 2 in a row now to figure that out. So for Boys Adventure, we don't know. That's your X plus 0.12 equals 0.48. All right, so what we're going to do is we're going to subtract 0.12s from both sides. 12s are out. X equals subtract 0.48 minus 0.12 is 0.36. Because 8 minus 2 is your 6. 4 minus your 1 is 3. So there's our boys' adventure there that we started out with that we couldn't figure out. So 0.36 there. Last one, we're going to find out the girls' adventure. We're going to use, you can go either way. We're going to just use the row. You can go up or down, which is your column, or your side to side, which is your row. I'll just use the row. X plus, and I'm loving the equal sign right now. So X plus 0.24 equals 0.52. Opposite of adding is subtract. So subtract 0.24, subtract 0.24. X equals, those cancel out, 0.52 minus, worked out handy because it's in the calculator from last time, 0.24 should give us 0.28. 0.28. And there we have it for the girls' adventure, 0.28. Okay, now the last thing is we got to figure out the question here. And the question is asking for how many more boys and girls prefer adventure movies? Okay, well, because we're talking about adventure, it has to be the girls and the boys right here. There's nothing mentioned about comedy, so that's completely out. All right, how many more boys than girls? Okay, we're going to take our boys, 0.36, subtract out our girls, 0.28 equals, well, use the calculator here. So we got 0.36 minus 0.28, which is going to give us a frequency value of I'll write it right here, 0.08. What's the total number of students for our frequency value? It's 50 students. So 50 students times 0.08 should give us 4 students. So times 50 students, and there's our 4 students. Perfect. So we got 4 boys that would prefer adventure movies compared to the girls. All right, last question. 6 questions later. Again, just taking my time because you only got to do 7 questions to get your score. But don't be careless. All right, we're going to fill out the frequency table. And what are we talking about? Looks like something with popcorn and candy, and boys and girls. We'll see what they like. Read the question first, so that way we can see what we're doing. So Anna asked 75 students whether they prefer to buy popcorn or candy when they go to the movie theater. This table shows the results. That is a good one. When you go to the movie theater, like, well, I don't know. I want the popcorn. I want the candy. Yeah, it depends, right? All right. The popcorn, we can do that one. We can do the boys' popcorn. So we have X plus 18 equals 41. All right, so first step is we're going to subtract 18 on both sides, minus 18. 18 throughout equals 41 minus 18. Got some borrowing there, just use the calculator. 41 minus that 18 is going to take us to, and I'm always checking back and forth, make sure I get it right, or at least plug it in the calculator right, is total 23. So I got 23. Now what I'm noticing on this one too is notice that we have 75 students for our total, and the 75 here is actually marked for the total. See, the total is how they collide. So this table is already set in the number of students. We don't have to do the frequency like before. There's no decimal. So watch out for the whole numbers and the decimals. So this one's just going to be straight at the end. Okay, candy is good there. Let's go ahead and clear the screen and figure out our total for the boys. So we're just going to add 23 popcorns plus 22 candies. We can do that. Let's see. We got 3 plus 2 is 5. Then 2 plus 2 is 4, so I got 45 on that one. So 23 plus 22 is 45. Clear the screen. Okay, now let's get into the girls and their candy. We got 18 plus x equals 30. So 18 plus we don't know equals 30. Subtract 18 from both sides. Minus 18, minus 18. So we got 30 minus 18. Should give us a total of 12. So we're plugging 12 there. And in case you're wondering, well, Mr. Painter, you didn't even finish the problem. Yeah, if you want to finish it, go ahead, cancel that out. X equals 30 minus 18, 12. And that's how I knew that went there. All right, clear the screen one last time because we are almost so close to being done. We need to find out the total of candy. So total of candy, we have 41 plus, I don't know, equals 75. Subtract 41 from both sides. Minus 41, minus 41. 41s are out. X equals 75 minus 41. 5 minus 1 is 4. 7 minus 4 is 3. So I got 34 on that one. 34. All right. Clear the screen. Last question. How many more students prefer to buy popcorn than prefer to buy the candy? Now, notice there's nothing mentioned about boys or girls because they're talking about students. We're talking about students. We're talking about the total. So the boys and the girls are not relevant here. And what does that leave us with? The only row for popcorn and the only row for candy. All right, so what we're going to do is we're going to do popcorn 41 minus the candy, which is 34. So we got 41 minus 34. 41 minus 34 equals 7. So 7 students would rather have that popcorn than the candy. So as long as I put that number in correctly, we're good. All right, there it is. Frequency table's all filled out. We got 7 more students that would prefer to buy popcorn than the candy. So scared to hit submit, but we got to do it to make it happen. And let's do it. Smart score of 86. This concludes this fabulous IXL tutorial for the checkpoint of GG.14 on two-way frequency tables. Have a fantastic day.